Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, we're back again with Babak Hodjat. Babak, can you do a quick intro about yourself?
Sure. My name is Babak. I'm the CTO AI for Cognizant, which means I uh, lead our AI R&D team. We do core AI research at our labs here in the US, in San Francisco, and also around the world, um, and help with the AI strategy for the company. My background is in AI. I have a PhD in AI. I've been in AI all my career. Wasn't as cool as it is right now. Um, and done 3 startups in AI and worked in larger companies as well.
Very cool. And so I hear you guys over at Cognizant, you've been cooking up something really big. And I hear that the name neural AI come up often. So can you tell us like what neural AI is and what this hot stuff that you guys are cooking up over at Cognizant?
For sure. Yes, you have heard correctly. The rumors are true. So we announced our flagship AI platform last year, actually, called Neuro AI. And Neuro AI comes out of my lab. And where what we do is we build decision-making workflows. And I think we talked about that last time on your podcast as well, which is, look, AI is not just about insights and predictions. Really, most insights and predictions are ultimately in the service of some decisions. And I don't mean just, show me the insights and the human makes the decision. I'm talking about the AI itself actually giving you a very specific, recommendation as to what to do. So those are the types of use cases that we can develop quite rapidly using Neuro AI. Now, one of the issues we had was that it really took someone with some knowledge of data science and AI to be able to use it. And we really wanted to get ourselves closer to the use case, closer to the business owner that understands the use case, because our whole point was, AI should be aligned with your KPI. So we should stop just selling AI as something that's more accurate. We should sell AI as something that's aligned with your business KPI. And that's what Neuro AI does. And of course, who knows the business KPI but the business owner? So we really needed to get closer to them. And the technology we chose to help us bridge that gap was a multi-agent based technology. And so we were one of the first, if not the first, to embrace multi-agent based systems for business AI enablement. And we used multi-agent systems to create neuro AI based use cases that were themselves multi-agent. So it's like agents upon agents. Um, and in the process of bringing multi-agent systems in, we came up with our own agentic framework. So that's what we basically announced last week, was the fact that we now have this version of Neuro AI that is agent-based. And so you can literally uh, talk to an agent, an AI agent, and identify use cases and then scope them and even build them. So the end-to-end process is through, you basically conversing with various different agents. Yeah.
Gotcha. So like what is like an agent? Can you explain it in like layman's terms for like viewers who are kind of new to the show?
Awesome. Yes, absolutely. Yes, agents. Um, there's a difference between agents and models. So if we've been talking about generative AI models, and even before that, ML-based models. And what models do is they have some inputs. It could be an image, and they have some outputs, like, is there a dog in this image? In the case of a large language model, which is things like ChatGPT and Gemini and Llama and so forth, the input is some text. So you've actually typed in some command or something, and the output is more text. Or in cases where you have multimodal models, could be that you're describing an image and the system actually produces an image. So there's an input and something that gets produced. Behind the scene, what the model is doing is it's kind of predicting what you would expect to see. And that's the basis of all models. Okay, but then we get agents. What is an agent? An agent can do stuff. So a model can produce stuff, an agent can do stuff. At the core, the brain of the agent is still a model. But it has a set of tools. So when the model produces, for example, a command that says, call this API or fill out this form, then the agent is able to actuate that and do it and come back and retrieve the result and have the model take a look at it. So that's the agent. Let me give you a simple little example of that. Like we all know that models can be used to write code, right? And it's one of the largest use cases currently of generative AI is coding productivity. We see all sorts of coding copilots and so forth out there. Um, so how does the model write code? Well, you give it the description of the code and it produces some code. Input comes in, output comes out. If the description isn't too complex, the code is going to be, executable right off the bat, or at least give you some sense of what you need to do. Okay, so that's a model generating code. So let's say we actually now have an agent that has that model in it, but also has some tools to execute code. The very same query to the agent, write this piece of code, it will still produce the code, but it will be able to run that code in a container, view the result of that code, maybe make adjustments and fixes if there are some runtime errors, and then come back to you with the code that it wrote. So the end result might be the same. I wrote you some code, but in one case, it just wrote the code, does not know anything about how this code is going to operate when you actually run it. In the second case, it actually ran the code in a container and came back to you. So those tools in this case could be, the ability to run code in a container. It could be, filling out this form and submitting it. Or it could be, calling some sort of microservice or an API or operating some sort of application. And so that's the distinction between an agent and a model right there.
Yeah, that seems very advanced. I would love to see like in the future, like coding assistants being able to take a piece of code, uh, like in Python, create a virtual environment, load all the libraries on there, and then run that code. Is that currently possible out there?
Yes, it is. There are agents that do that. In fact, one of the first use cases of modern agents, agents have been around for quite a while. I mean, in the 90s, people built agents. I wrote a paper on agents in 1999. So they have been around, but the modern day agents, the core, the reasoning piece is a large language model. So it's very new. Um, and and most of us who are in AI also write code. So one of the first use cases of agents has been in writing code. And in fact, I gave an example of a single agent writing code. What's amazing is that you can actually have a community of agents that are writing code. So you can have an agent that is a project manager, and opening tickets and closing tickets. You can have an agent that writes pieces of the code. There's an agent that kind of coordinates it. It could be front-end agent, back-end agent, QA agent, some agent to write unit tests. So you can actually have a whole team that's writing code and running the code in containers and so forth, and running the unit tests and then coming back to you. So those are some of the initial use cases, mostly in research, that people have been trying out, even in multi-agent based systems. And the reason why is because um, as AI folks, we write code, so we're familiar with that. The other thing is that it's easier to measure whether or not code is working, especially if you have a coding benchmark, what the actual behavior that you expect is going to be. So it's easier to benchmark these systems, and there are some really, really interesting, cool, useful coding benchmarks. So you can take these single or multi-agent systems, have them try to solve all the problems in the benchmark and get a sense of how well they work. So those are the reasons why coding is a popular use case for agents, but that's not the only use case for agents, obviously.
Yeah, I've seen a lot of people like use Gen AI for like letter writing or like content creation. And you spoke of like benchmarking. So how would you like benchmark like a letter writer or benchmark like content creation? Is there like any best practices out right now, or is it just kind of like you like a human has to come in there and like manually visually take a look at the output and then give it a thumbs up or a thumbs down?
Yeah, that one's harder. That one's harder, especially because the models are really not consistent typically, and so the same query can produce different results. And you're actually assessing the output. You're not assessing, you're not when you're writing code, you're assessing the behavior of the code. So it's kind of a genotype, if you like, to use a biology analogy. There's a genotype that is produced, which is the code, and then there's a phenotype, which is, you run the code and it's the behavior. And it's easier to expect consistency on the behavior of the code than the code itself. Like even in humans, coders, you have coders write the same code. The results might be the same, but the code is going to look different. So that's what we're dealing with here. And even there, when you're talking about like writing a letter or doing, creating an image or, so forth, I think the best kinds of benchmarks are those that are, viewing certain elements within what is produced and making sure that they're there or they're not there, or they're using, rule-based ways to assess to make sure, grammatically it's correct and, it hits the topics that you wanted to hit and doesn't go off and do something else. Or for example, if it's giving citations, those links actually work. Those sorts of things could be some ways to assess, but it's definitely harder.
So last year, the big hot stuff was retrieval augmented generation or RAG. This year, the big hot thing that I'm seeing is that agentic workflows are like the new hot kid on the block. Can you give us some background on like what agentic workflows look like?
Definitely. So one of the things that's happening is that there's a lot of attention being paid to agent-based systems. Typically, what we're seeing is people announcing agents and platforms to create agents for various different uses. For example, Dreamforce is now called Agentforce, and there is this whole platform for creating agents. These are single agents, typically. I think ServiceNow has one, SAP has one, and people are coming out with their agents. And these are single agents that are sitting on top of certain functionality, let's say your Salesforce installation, and they're able to do various different things on your behalf, like an assistant would. And again, the keyword is an agent can do stuff, and therefore they can actually pull the levers and make calls and such. But what we're seeing is this gradual move and requirement for you to be able to take these agents and connect them to one another. And that's the agentic workflows that you just talked about. So one agent being able to talk to another agent so that in coordination they can fulfill whatever requirement you have or query and inquiry that you have. And it's kind of happening organically. It's kind of happening in a way that people aren't even conscious that it's happening. And I'll give you an example. Let's say you have your intranet. You have employees come in and they go to this page and it's a collection of apps that they can use. Now the intranet is going to have a search box, so you can go to the search box and type in some keywords, let's say payroll, and it'll take you to the payroll app. And then you go into the payroll app and you probably have to use its search box to kind of get to whatever you're looking for. Now, of course, a lot of companies, including ours, have started replacing or augmenting that search box with a retrieval augmented generation system, so that you can actually type in natural language what you're looking for, and it actually finds the apps. It's much more expressive. It's intent driven. It can actually retrieve some data for you and such. Okay, but the problem is that it will only go so far. Like the intranet itself is owned, let's say, by the IT department, but if it's actually now redirecting you to the HR app is owned by the HR department if you're large enough like we are. And they've probably gone down and created their own RAG interface into their HR app. And so it just doesn't make sense for you to have to repeat your query back to the HR app, or when you actually come back up and talk to the home screen agent, quote unquote, for it to forget what you were talking to the HR app about. And so just organically, it makes sense for these apps to talk to each other, these agents to talk to each other. And right there, you can kind of see a type of an employee workflow that's kind of emerging from this need for these apps to talk to each other. And it's relatively easy to build because the agents at their core, as I said, their brain is large language models. They understand language. And so they can actually talk to each other regardless of what the API, specific API call is to the specific functionality. The apps themselves can talk to each other now in an intent-based natural language form. Um, and so it makes for some interesting. So actually, why don't I? Can I give you a demo?
Oh yeah, I would love to see that.
Okay.
So for viewers at home, if you're traveling, we're gonna try our best to verbally describe what he's showing on the screen, and then for folks that are watching on video, I mean, you can just follow along with the screen share.
Okay, awesome. Yeah, I'll try to be descriptive. Um, Yeah, so here you can see um, the this is the multi-agent system framework that we built in order to make Neuro AI multi-agent based. And let me just load the intranet example, so just because we were talking about it. And you can see here that I just loaded the agent network. There's this graph that shows the connections between the agents. And at the center is the main search box agent. So this is the agent that's responsible for the intranet itself. And then you have the finance agent, the legal agent, HR agent, procurement agent, and IT agent connected to it. These are down chain, but they're presumably created by the owners of those apps. Each one of those have their own down chain agents. For example, the procurement agent has the contract negotiation and the vendor management and the purchasing agents as down chains. And those could each be like created and maintained by a different department, but they're all connected. And that connection basically denotes how these agents would be talking to each other. They are going to not know what each agent's scope is. And that's the beauty of this particular agent architecture that we've used, is that the main search box really doesn't know the innards and the specifics of the HR agent. And all it does is it talks to the HR agent and says, hey, I have this query. Is this something you can help me with? And so through that discussion, let me actually give you an example. Let's say I type in something like our network is down, which is typically, it's very intent based. So I don't really know which agent is going to help me. What's going to happen is you can see the IT agent lit up. And then it talked in turn with the network agent and the security agent. And they returned back to the IT agent, which in turn returned back to the main search box. So what happened here is that the main search box asked the agents, HR and legal and finance and procurement probably said, hey, you know what? It has nothing to do with us. Like the network being down is not us. But the IT agent is like, wait, I think it's mine. Let me check with networking. Let me check with security. And it came back. And both of them actually reported. So you can see here that both the security agent and the network agent have returned back some information and have asked some questions back to the user in order to be able to service them. And it's all been consolidated into a single response back to the user. So this is the power, this like silo smashing power of multi-agent based systems, is the fact that, you don't have to stay on hold while, you're being redirected to someone else to then have to repeat the whole thing all over again. You just type in one thing and the whole agent network is kind of resolving it for you. Now, you might ask, so, okay, how do we use this technology to build decision-based systems? So maybe now that I've shared my screen, by the way, on the left-hand side, I don't know if you notice, those of you who are watching, you probably have noticed that there was some dialogue. So it actually showed these agents kind of chatting with each other. I just have my the behind the scenes open here as well. So let me, if you agree, I want to go show you this latest version of Neuro AI. and show you how agents kind of cooperate beyond something like intranet or writing code to help build these decisioning systems.
Yeah, I'd love to see it.
All right, so I have it right here. This is Neuro AI 2, and it is a multi-agent edition and really designed so the business owner can actually interact with this thing. I don't want any AI person or data scientist involved in that first pass as we're identifying the use case. So we're going to go into the opportunity finder, and the opportunity finder right off the bat, you can see there are a number of agents lined up here to help me. Now I can talk to any of these agents. Remember, these agents understand natural language. I can just go directly to the scoping agent and say, hey, I want to build this particular system, and it's going to scope it for me. But what if I don't know what I want to build? Oftentimes when I talk to clients, they're back in that mindset of, oh, AI should be giving me, insights. So that's why I like to start with the opportunity finder. And here I would be typing in the name of their company or corporation or I don't know, what should we type here? Just to impress you, I'm gonna type your name in. How about that? So I typed in your name as a podcaster. And so what this agent is going to do, it knows about Neuro AI and it will search you online and find out who you are and what you do. And it's asking me, is there a specific area you want? So yeah, list any podcast related areas. Sometimes you really need to nudge it. And so now it's actually going to list a number of use cases that it thinks the system that it thinks would be useful for you in your job as a successful podcaster. And so you can see here that it's actually suggesting episode topic selection, advertisement placement and selection, social media promotion strategy, audience growth initiatives, and content monetization strategies. So I see you nodding your head. I want to make sure, are these in line with what you expect an AI-based agent to help you with, or do any of these look interesting for us to
Yeah,
build?
yeah, definitely. Like episode topic selection is a big one. So
Okay.
I was trying to find like the next big hot topic to kind of stay on top of the SEO.
Okay. All right, let's go with that. I've never built a use case for that. Now, you can see here that what it selected as the one that it thinks has the most bang for the buck is advertisement placement and selection. And it actually does an ROI analysis on that. Like what kind of savings would be in there if we go in and use Neuro AI for that topic. But we can always ask it to do the same. So I'm still staying with the same agent, but I'm asking it to do the same for the topic selection, and it's actually doing some calculations, and it'll come back to us and say, yeah, here's kind of the savings you're looking at if you had an agent helping you with the topic selection. And take the numbers with a grain of salt, but it's the reasoning really that we care about. And so the next thing we're going to do is we're going to go to the scoping agent, and we're going to have the system scope this particular use case. And so there's going to be some detailed scoping. Hopefully some of the attributes that are listed here are going to be more familiar to you than it is to me. But the first thing I would like to ask you is it's listed some attributes which are the outcomes. These are the KPIs that you presumably care about. And they're listener engagement, feedback score, and cost. So presumably, again, we're looking at improving or increasing listener engagement, increasing feedback score, but at the same time, containing and reducing costs. Are these the criteria you would have in mind for a system like this?
Yeah, so like listener engagement, the thing that everyone kind of looks at is like how many downloads, how many shares,
Hmm.
the median time play time.
Yeah.
So that those are like very important metrics to like a show.
Definitely. So we could replace this general listener engagement attribute with those constituents, or we can expect the system to actually derive a score for listener engagement based on those constituents. And for now, just for the sake of time, I'm just going to stay with what it produced. But this is actually the agent with whom we're going to be interacting a lot when we're building a use case. So people are going to say, oh, I do have some data on this attribute. I don't have anything on that. Or this action is, I don't care about it, but I care about this other thing. And so we go back and forth and interact. But for the sake of time, I'm just going to now ask it to generate 1,000 rows. Um, and so what am I doing here? I'm going to the data generator agent. I clicked on that agent now, and I asked it to generate 1,000 rows of data. I don't have access to your data, your SEO scores and your episode metadata or data and so forth. So what I'm going to do is I'm going to generate some synthetic data that's going to resemble the data that I think will be available to you. Knowing you, Tony, you probably have collected a ton of data on your episodes and stuff. So we can actually tap into that once we actually build this. But for now, just to give you the art of the possible, I'm going to generate the data synthetically. Some patterns are going to be built into that synthetic data. So it's not going to be completely random, but it will get us past this step. And then, so I'm just going to take a quick look at the code that is generated. It looks pretty much in line with what we scoped. And so next I'm going to say create the use case and include uncertainty. So this is I'm kind of showing off here, but what I want is to have these agents work together and based on the description and this interaction that you and I had to actually build this use case. Now, you can see this step is completely autonomous. So the agents, there are a bunch of agents that are going to be talked to by this orchestrator to go off and build this on our behalf. It's as if we have a data scientist or a team of data scientists or AI engineers at our disposal. And those are these agents, and they're going off and building this. And so I can show you, I'm just going back to the multi-agent system client that I showed the intranet on, and I can just show you the behind the scenes of the opportunity finder pipeline. So this is exactly why we built this system, was to create this kind of multi-agent system that you can see here has the opportunity finder. This is the orchestrator agent, but it has a bunch of down chains, including a synthetic data generator that we just talked to, the field describer, the data profiler, the project describer. Ultimately, it'll come down to experiment creation and then experiment controller. So these agents are going to work together to build this and give us basically our experiments are defined in HOCON files. It's just a glorified JSON in which you can put comments. But this is what the orchestrator and these agents are doing. They're actually constructing this on our behalf. This might take 2 or 3 minutes. While it's working, let me just show you how powerful this system can be. So obviously I showed you the intranet. I showed you this one, which is our opportunity finder. But here's where the future is going to go. We're actually going to create agentic workflows that mimic our current processes and business workflows. So let me show you, for example, a telco network support use case. So I just loaded that. You can see here, I have a bunch of agents, and probably my entry point is the customer support rep, but it has downchain agents that include the network engineer, the account manager, the service delivery coordinator, all manners of functions. They end up talking to a field technician, a logistic coordinator. So this is a mirror of a number of workflows that this telco is covering, and it will augment and improve these workflows so that I can go in and say something like, our network is overloaded. Maybe I need a quote for an upgrade. And the reason why I put this in is because it's a two-pronged query. Like my network is, overloaded. I need, a service rep and, someone to come in and check to see what's going on right now to fix it. But then at the second part, I'm like, maybe I need an upgrade. Maybe I have too many employees now on this network, and you need to kind of come back to me and give me a new design. And the system comes back, and you can see here that it's actually talked to a network operations center, basically a knock specialist, a field technician, a sales engineer, and a project manager to help me fix this issue, as well as to the field technician and the not network. So this basically is bringing together a number of teams that can help me with all aspects of what I do. So the future is going to be us going in, identifying these business workflows, and building multi-agent based systems that resemble these workflows and then can cover sometimes autonomously, these relationships and help the business become more robust and more productive. Um, so this is still running. I know that we're kind of we might be running out of time. I actually built one before, so I'm just going to show you just what you are about to see once this thing completes. Um, but what you're about to see is this thing. So the system is going to actually, and this one actually was automatically generated. You can see up top it says, hey, be careful, this was automatically generated by agents. But it's basically agents putting agents together to help me with my decision flow. And in this case, we've built a system with outcome objectives, which is similar to what you are looking for: listener engagement, feedback quality, and production cost. And you can see that it used its reasoning to decide to maximize listener engagement and feedback quality and minimize production costs. I didn't tell it to do that. It's just using its own common sense reasoning for that. And I can add more, like as a human overseeing this, I can actually add more modules here and make changes. It's actually added the uncertainty models. I can use other agents. So maybe I want to talk to this data agent and ask it to, create a useful chart on the data. Now, the data is synthetic, but it's fun because I don't know what it considers useful. I'm kind of deferring to it, and it built this chart that says, hey, depending on the content type, whether it's an interview, narrative, panel, or solo, here is the sort of average listener engagement that you can see. So that it's considering this chart as being useful for me. The other thing I can do, which is really cool, is I can actually have another agent view this design that was made by other agents and kind of give me some feedback. Here's how well it's doing. Here's where you need to make some changes, modifications. Here are some recommendations. So this is the example of a safeguard agent checking the work of other agents and getting back to me with some recommendations. And you can see here that there are some action items that is produced for me to consider to improve this design. And then finally, I just train this. It's a no-code platform, so it will actually produce all these steps in a Jupyter notebook with ample Python code that we can go in and customize. And I can go in and actually look at the art of the possible. So how well is the system, from a mean absolute error perspective, able to predict these various different KPI like listener engagement, feedback quality, and production cost? And then, with training, I mean, we didn't train it enough because we didn't have a lot of time. But with training, is listener engagement improving? Yeah, it is improving a little bit. Is feedback quality improving? Yeah, it is. And is production cost coming down slightly? Yeah, it looks reasonable. And then of course I can plot all three next to each other, right? So I can do this as parallel coordinates. So a question I would ask from you is, which one of the three outcomes is more important to you? Listener engagement, feedback quality, or production cost?
Definitely the listener engagement.
All right, wonderful. So I'm gonna take the top listener engagement ones. I'm gonna assume that feedback quality is the next one. So we're gonna take the ones that have the highest feedback quality. And of those, I can see that there's one AI system that produces less costly options. So I'm gonna just take that. So each line is an AI system here in this chart, and I'm going to select the AI system that gives me that balance of listener engagement, feedback quality, and production cost. I'm going to go in and actually try it. So you can see how quickly we actually built an end-to-end system, and we're able to go in and run what-if scenarios. So here is, the past episode performance. That's an indicator of the current episode performance. Here's the listener age range that you're targeting. Here's the gender, listener location. I don't know if it's Africa, maybe it's mostly North America, social media engagement, blah, blah, blah. So we enter a use case and we ask the AI. Now the AI agents are working together and coming back to us and saying, hey, for this one, let's do a topic on education. I don't know if you've had topics on education, but let's do education, have one expert. This is the budget we should allocate to it and the amount of effort. It should be in an interview format. And let's time it for a weekend. And if we do that, then here's what we're going to see from a listener engagement perspective, feedback quality. Oh no, that's negative. So we're going to ask it to change that, and production costs. And so I can then ask it to explain why it wants me to do this. And what's cool is that it can actually give me an explanation. Here's why I want you to do this, and here's the potential risk and bias and mitigation strategies. So a very explainable approach. But we don't like feedback negative, so we're going to go in here and say, how can we make sure the feedback is positive, right? So, everything can have a ChatGPT-like interface to it, and this will make calls to the various different models in the back end and come back with a very specific, recommendation as to what to do for this particular episode and this setting, in order to improve the feedback quality. So it will now highlight that answer here, and the answer is you can see here the prescribed actions to maximize positive outcome is this, this, and that. So it's giving you a very specific outcome. Yeah, so just wanted to show you this.
That sounds really cool. Like if I were listening in and I was really interested in neural AI, like how would I contact you?
Yeah. So first of all, drop me a line. You can hit me up on LinkedIn, or you can just drop me an email. It's babak@cognizant.com. So very, very simple. If you're interested in neural AI. And what we've announced, which is really exciting, is that a business can actually take this and install it and run the whole thing on-prem or within their own environment. So up until now, Neuro AI has been something that we've hosted on behalf of our clients, and that option still exists. But then we as Cognizant would be using it on behalf of our clients. But now, as of last week, we've announced that the system is available for clients to use directly.
That's really interesting. So if you're like a company that deals with like PHI or PII data, can you bring the neural AI into your own tenant that has an air gap?
Yes, you can. You can. The entire thing will run within your tenant. Now, if you want to use more powerful LLMs behind the agents, then we recommend that you use a commercially available LLM, and it's easier to install. But for some clients, they might not even want that. And it is more expensive, but we have the option to actually run open source models for you on-prem. So none of the data is ever going to leave your premises when you run the system.
Well, that's really exciting. So at Cognizant, what's next for you guys?
Yeah, so we are obviously going out with this Neuro AI, and we hope to have many installations and support our clients in using these agent-based systems for their decision making, but also in agentifying, if that's the word, Neuro AI. We have a lot of experience creating these agent-based processes that might not necessarily be decision-based. I showed you a couple of those. And so we now are announcing an offering whereby Cognizant can engage with a client and can actually identify various different business workflows and build the agent network in a very responsible, human-centric manner to augment and improve these workflows for our clients. So there is an offering forming around the technology that you just saw that we're bringing to market.
That's very exciting, man. I'm happy that you guys got onto the show to showcase this awesome neural AI. Um, really excited to see the evolution of neural AI as you guys move it into the future. Because I know that agentic workflows right now are like the big hot like topic. Are you guys seeing that as well across the various industries?
We are seeing this agent-based systems are getting a lot of attention. We're getting a lot of inbound on them, and then just multi-agent based systems is the next big thing. We I think we're the only commercial company out there that's really promoting that as a business solution. And we have the world's foremost research lab around it and platform around it. But we do think that that's going to be huge as well. And we're not going to be alone in promoting multi-agent based systems.
Well, thanks so much for being on the show. And until next time, stay curious.